This video is about applying the properties of quadrilaterals to shapes and true-false questions. So in the first part, we need to determine, based on the markings, state the most specific name of the quadrilateral that is represented in the figure, explain your reasoning. So in number 1, this has 4 sides, so this would be a quadrilateral because it has 4 sides. In number 2, we have a shape that has 1 set of parallel sides because of the arrows. We have 2 sets of consecutive angles that are congruent, which in this case would be our base angles. So this would be an isosceles trapezoid. And we know that because it's got 1 set of parallel sides and 2 sets of congruent base angles. Number 3, we have 2 sets of parallel sides because the side on the top and bottom have 1 arrow, and the sides on the left and right have 2 arrows. So the first shape that has 2 sets of parallel sides is a parallelogram. And then we know that because it has 2 sets of opposite sides parallel. Number 4, we have a shape with 4 right angles. We know nothing about the sides, so the first shape that has right angles is a rectangle. So the shape is a rectangle because it has 4 right angles. In number 5, we have a shape with diagonals, and they are bisecting the opposite angles. So the first shape that has that property is a rhombus. And our reason is because diagonals bisect the opposite angles. Number 6, we have 4 congruent sides because they all have the same tick mark and 1 right angle. So this is a square because it has 4 congruent sides and it has a right angle. Number 7, our shape in our diagonal, only one of the diagonals is bisected, and they are perpendicular because this is a kite, which means that the diagonal is a perpendicular bisector of the other. In number 8, both diagonals are bisected, but they have different lengths because one set of diagonals only has 1 tick mark and one has circles. So the first shape that has diagonals that bisect each other is a parallelogram. And this is because diagonals bisect each other. Number 9, we have diagonals that are bisected and all 4 pieces are congruent, which means that the entire diagonals are also congruent, and the first shape that happens in is a rectangle. So we know that because it has 2 congruent diagonals. So let's look at some true-false questions now. So in a true-false question, we're seeing using either properties or relationships, is it true or false? So is every rectangle a square? Well, squares have rectangle properties, but not every rectangle is going to have 4 congruent sides, so this is going to be false. Number 11, the diagonals of a square bisect the angles they pass through. Well, that's a property of a rhombus, and squares get their property from a rhombus, so this is true. All rectangles have 4 right angles. That's a property of rectangles, so that is true. 13, a kite is a parallelogram. So a kite has 0 parallel sides, and a parallelogram has 2 sets of opposite sides that are parallel. So because kites do not have parallel sides, it cannot be a parallelogram, so that would be false. Now let's try some trickier true or false questions. Instead, this time we're going to do sometimes, always, never. So an always question means that it's always true. A sometimes question means that we can think of a case where it's true or false, and never true is when it's always false. Now, with these questions, one thing that might be helpful to remember is our family tree. So remember, on the top of our family tree, we have quadrilaterals. Those go down to parallelograms, which splits to a rectangle and a rhombus, which come back together for squares. Remember, with our quadrilateral, we also have a trapezoid. And more specifically, we can get an isosceles trapezoid. On the other side, we also have a kite. So, is a square a trapezoid? Now, squares and trapezoids do not share the same, there's no branches connecting them directly. So because there's no branches connecting them directly, this is never. We also know it's never because a square has two sets of parallel sides and a trapezoid only has one. 15, in a rectangle, the diagonals are bisected into four congruent parts. Well, that's a property of a rectangle. Remember, we just talked about before that the diagonals are bisected into four equal parts because the diagonals are congruent. So this is always. In a trapezoid, the non-parallel sides are congruent. Well, in a trapezoid, it doesn't have any congruent sides, but an isosceles trapezoid does, so this would be sometimes. 17, a rectangle is a parallelogram. Well, remember that rectangles get properties from parallelograms, so because I'm moving up the family tree, this is an always. A rectangle has four congruent angles and sides. So we know that rectangles have four right angles which are congruent. But rhombuses have the four congruent sides. So for a rectangle, if it also has four congruent sides, it'd be a square, which would share rhombus properties. So this is a sometimes because they're connected through using another shape. 19, a parallelogram is a rhombus. So this time we are going down the family tree. So it could be a rhombus, but it could also be a rectangle. So this is just a sometimes. Determine the most specific shape that is described in each sentence. So a parallelogram has four right angles. So the first shape that has four right angles is a rectangle. 21, a quadrilateral that has two sets of consecutive sides congruent. So that means it has two sets of sides that are congruent, which would be a kite. A four-sided quadrilateral, or polygon would be a quadrilateral because that's our most specific thing that has four sides. A quadrilateral with one set of parallel sides, remember the shape that has one parallel set of sides is a trapezoid. Based on the given information, what is necessary to prove ABCD is a parallelogram? So if B is parallel to D, that's one set of opposite angles. So we would need to know that the other set, A and C, are also congruent. If we have BC is parallel to AD, we need to know either the other sides are parallel, so CD is parallel to BA, or we need those sides to also be congruent. So remember, there's two conditions that would work to prove it's a parallelogram. In C, we are given that CD is congruent, to BA. So again, we have two options. We can say the other side, CB, is congruent to DA, or we can say that set of sides needs to be parallel.